Welcome. So this is the last part of Chapter 12, which puts all of these pieces of the puzzle together that we've been learning in the last several chapters. Now, what I'm going to show you here isn't actually outlined in the textbook, but I think it's useful to actually go through the steps of solving this somewhat complicated model, but it's tractable nonetheless. And so the whole point of this is that if we look at what we did in Chapter 9, we built this IS equation in this IS curve. And then in Chapter 10, we looked at the MP curve and saw how the IS and the MP curve could come together to derive an aggregate demand curve. And then in Chapter 11, we talked about aggregate supply. And then in Chapter 12, we're actually putting all those pieces together to understand how they operate mechanically. And so we learned the visual and sort of the numerical representations of that in some of the examples in these chapters. But what I'm going to do is go through sort of the theoretical derivation using these generic frameworks to put all the pieces together and look at the equilibria that result. So as I mentioned, we have these IS and MP curve equations, and so the idea is when we put those two things together, that allows us to have an aggregate demand curve. So for instance, the IS curve looks like that thing right there, and again, I'm not going to go through the derivation of that. That is all comes from Chapter 9. And then we have the MP curve, which helps us try to explain how monetary policy operates in a simplistic way. And essentially, policymakers are adjusting the short-term real interest rate from a proxy of a short-term nominal interest rate in order to achieve its objectives. And so the idea is simply that if we put these two pieces together, when we put these things together here, we substitute this thing into there, and it turns out we can solve for this and get our aggregate demand curve, which is this ugly equation here, and it's all based upon these underlying foundational parameters. So all of these autonomous spending parameters, financial frictions, all that kind of stuff, taxes, the MPC, which is governed by the consumption function, and then we have all of these individual sensitivity parameters to the real interest rate as well, and then you throw in this piece here with lambda. So it turns out if you put all those things together, you get this aggregate demand curve, which you'll notice is a function of inflation. And again, we have this minus sign there, which means that as inflation goes up, the amount of output demanded goes down and vice versa. So when we crunch all of that stuff together in these generic forms, that's what our aggregate demand curve looks like. And so in an equilibrium in the short run, the idea is simply that we're going to be setting the aggregate supply, that is the short run aggregate supply curve, equal to the aggregate demand and solving. Okay, so intuitively, that's our short run equilibrium, where aggregate supply intersects aggregate demand. And so in order to solve for our short run equilibrium, very simply, we're going to put those two things together and solve. And so we're going to set our aggregate demand curve equal to our aggregate supply curve and solve. So in other words, we're going to find a point where those two things intersect. So as I just showed you, our aggregate demand curve in its general form looks like this ugly equation right here. And in Chapter 11, we derived an aggregate supply curve, a short-run aggregate supply curve that looks like the following, where inflation depends upon inflation expectations, this output gap term, and any presumably temporary price shocks that occur as a result of that. And so in order to solve for this short-run equilibrium, again, just like what we looked at before, very simply, we're going to substitute our aggregate supply curve into our aggregate demand curve and solve. And so we can solve for a function of everything else and solve for y as a function of everything else. And so if we do that, then this is the big ugly equation that we get. Okay, so when you're doing numerical examples in the textbook, underlying it is this big ugly equation right here, as it turns out. And so in this generic form, it looks rather complicated, but again, it's nothing different than what you've done in some of the numerical problems in the textbook or the study guide. Now, I should mention one thing too here. We're assuming this basic form of inflation expectations where we're assuming that price and wage setters form inflation expectations based upon what they believe inflation was last period. So that's what that subscript -1 means, okay? So we're assuming this adaptive inflation expectations framework. So as I said, when we put aggregate demand, the aggregate supply function into our aggregate demand function and solve, this equation here is what results, okay? And so this is the reason why this is, I think, important is, number one, you can see sort of how to solve for this. And by the way, I encourage you to take the time to walk through the steps of solving and getting to this equation right here, okay? So the second point of this, which is, I think, instructive, is to be able to say something about what changes short-run output, short-run equilibrium output. And so we can say a lot of things about what affects our equilibrium level of output in the short run. And so, for instance, an increase in autonomous spending, that's C bar, I bar, G bar, or an X bar. Any of those things are going to affect our short-run equilibrium level of output. Again, the idea here is that's going to increase aggregate demand, and with an increase in aggregate demand, output in the short run is going to rise. A decrease in taxes, again, this is also going to result in an increase in aggregate demand. An autonomous easing of monetary policy. So if R bar goes down at any given inflation rate, what that means is that investment is going to rise and aggregate demand, therefore, is going to increase. And so that's going to result in an increase in aggregate demand, which gets us to an increase in output in the short run. A decrease in inflation expectations. This has the effect of shifting down our short-run aggregate supply curve. And so that also it also increases equilibrium output in the short run. It turns out that an increase in potential output also results in higher short-run output. You can see that that shows up right there. And so we have a minus sign there and a minus sign there. So when potential output rises, we have minus times a minus, that's a positive. So output in the short run is also going to increase as a result. A decrease in price shocks, again, that has the effect of shifting down our aggregate supply curve and therefore increasing equilibrium output in the short run. And then a decrease in financial frictions. Again, the idea here is that with a decrease in financial frictions at any given safe real interest rate, a decline in financial frictions reduces the real interest rate for investments that firms face, which means they're going to increase investment demanded, which is going to shift the IS curve to the right, and also, of course, that's going to result in an increase in aggregate demand. And so these are the basic things, and you can see exactly in this equation here with the pluses and the minuses exactly how these things should affect our interpretation of this. And so these are the basic factors which are going to be pushing and pulling on equilibrium output in the short run. Here we're assuming that the parameters C, D, X, and the MPC curve, the marginal propensity to consume, as well as gamma, those sort of underlying parameters are going to be fixed or constant. And so those aren't necessarily things that are going to be changing over time as a result. And so if we go to the smartboard, we can see an example of exactly what this looks like. And we're going to focus on the aggregate demand and the aggregate supply ones as well. So here, again, this is the basic way in which we can generate an increase in output in the short run, either through an increase in aggregate demand because of the factors that I just talked about, autonomous spending increases, decline in financial frictions, all that kind of stuff, or alternatively, a shift downward, a positive or beneficial or advantageous supply shock, if you will, I guess. So in that case, when the aggregate supply curve shifts down, again, you can see our equilibrium level of output is going to rise in the short run equilibrium. Okay, so those are the two basic mechanisms through which we can get increases in output in our short run equilibrium. And again, the whole point of that is that that's going to occur where our aggregate supply curve, the short run aggregate supply curve, intersects our aggregate demand curve. That's what generates our equilibrium output in the short run. Okay. Okay, so we just went through the output story in the short run. What about inflation? Well, this is fairly straightforward. Again, the basic way that we get to our equilibrium level of inflation is to simply substitute our equilibrium level of output back into our AS equation and solve, okay? So from the previous slide here, oops, right there, so we have our equilibrium, oops, we have our equilibrium, I'll get it, okay. We have our equilibrium level of output in the short run, Y star. So if we substitute that into our aggregate supply equation, which looks like this, substitute Y into that aggregate supply equation and solve for inflation as a function of everything else, this is the equation that you get right here. And again, you'll notice we're assuming that inflation expectations are just this one period backward-looking adaptive expectations to simplify things. So we get that big ugly equation, which is our short-run equilibrium level of inflation as a result. And again, I encourage you to take the time to go through the steps of math to solve out for this result here. So there's our equilibrium level of inflation in the short run. So again, we can look at this and make some basic inferences about what's going to be affecting inflation in our short run equilibrium. And so again, we have an increase in autonomous spending. That increases aggregate demand. And as a result, inflation goes up in the short run, right? A decrease in taxes, again, that increases aggregate demand, which also increases inflation in the short run. An easing of monetary policy, as we mentioned last time, that also has the effect of increasing the aggregate demand. So, excuse me, our short run equilibrium level of inflation goes up. An increase in inflation expectations, that has the effect of shifting up the aggregate supply curve. So for a given aggregate demand, level of aggregate demand in the aggregate demand curve, when our short run aggregate supply curve goes up, inflation goes up. Price shocks as well has the same effect. That's going to shift up our aggregate supply curve. So if we get an adverse price shock, so when rho is positive, at any given level of output, inflation is going to rise as a result, so that aggregate supply curve shifts upward. A decrease in financial frictions, that's going to result in an increase in aggregate demand, which again in the short run means inflation is going to rise. And then we have another one which we didn't have when we talked about output in the short run, which is the effect of lambda here. And so you can see that, where's lambda? Oh yeah, so lambda is actually in the denominator of these guys right there. And so when lambda goes up, the value of this thing in the denominator is going to go up, which means, let's see. No, sorry, when lambda goes down, we're decreasing lambda, okay? So when lambda goes down, the value in the denominator is going to get smaller. That's the thing on the bottom, right? And so that means that since that thing on the bottom of both of these equations, these parts of this thing here are going down, then inflation is going to rise as a result. That thing, the overall value is going to go up. And so that's important because that lambda parameter, if you recall, here's our MP curve. It says that policy interest rates are going to be governed by this autonomous policy interest rate. And then it's also going to be governed by this lambda parameter, which is effectively how sensitive monetary policies are to changes in inflation. A larger lambda means effectively that policymakers are going to be more aggressive in fighting inflation, and a lower lambda means that policymakers are going to be less aggressive in fighting inflation. And so the less aggressive you are at fighting inflation, that is a decrease in lambda, that means that at the end of the day, you're going to have a higher equilibrium level of inflation in the short run. And so it has important implications for thinking about stability of inflation in the longer term and and why central banks are so concerned about keeping inflation low and stable in order to keep inflation expectations anchored. And so again, you can see that through that lambda parameter there and how that affects the equilibrium inflation in the short run. So again, if we go back to the smartboard, we can see these basic factors and how they affect inflation in the short run. And so here you can again see the two basic stories here. When aggregate demand goes up, again, that aggregate demand curve shifts up. You can see our equilibrium level of inflation in the short run is going to rise. Likewise, when we get an increase in inflation expectations or higher positive price shocks, our aggregate supply curve shifts up, and we end up at a higher equilibrium level of inflation in the short run. Okay. So those are what affects our short run equilibrium in looking at this very detailed framework. And so the other question is to think about the long run. If we can get the slide, there we go. The other question is, again, to think about the long run and what affects these factors in the long run. What does the long run equilibrium look like in this generic framework here, and what drives our long run equilibrium? And so the basic story that you've seen before is that if, for whatever reason, we're in a short run equilibrium that's not where output is equal to potential, this self-correcting mechanism is going to move us back towards our potential level of output. And so the basic story is that, whoops, the basic story is that in a long-run equilibrium, we know that output is always going to be equal to potential output, whatever that may be, okay? And so that's going to make our life a little bit easier because we no longer have to worry about, well, what does the long-run equilibrium level of output look like? It's just whatever potential is, and those are dictated by other factors that just drop from the sky that are predetermined. And so if there's any shocks that occur to the economy that push us away from this long-run equilibrium, then the self-correcting mechanism is therefore going to push us back towards a long-run equilibrium. That means that output, again, is going to stay constant, but you'll notice that inflation can change. We can move to different long-run equilibrium inflation rates, and so that's the interesting story that we're going to look at here. So in a long-run equilibrium, all of those things are going to cross. We're going to have the long-run aggregate supply curve crossing the aggregate demand curve, which is also going to be equal to the aggregate supply, the short-run aggregate supply curve. So a long-run equilibrium then occurs where the long-run aggregate supply curve intersects the aggregate demand curve, which also intersects the short-run, the AS curve, the aggregate supply curve. And so a long-run equilibrium is necessarily a short-run equilibrium because it's got to be the case in a long-run equilibrium where AS intersects AD. But the reverse of that is not necessarily true. You don't have to be in a short-run equilibrium is not necessarily a long-run equilibrium. Okay. So as I mentioned, in the long-run equilibrium, output is equal to potential. And from the aggregate supply curve, the implication then is that inflation is just going to be equal to inflation expectations. And so what that means is that in a long run, people are going to be correct. Their inflation expectations are going to be exactly equal to whatever actual inflation is. It doesn't make sense for it to not be because then people would not be correct. They can just look out the window and see if it's raining or not and say, yep, I was right, or no, I was wrong. And so it's got to be internally consistent that in the long run, inflation has to be equal to inflation expectations. And we're also assuming in the long run that these shocks are equal to zero. So we're assuming these row shocks are temporary and don't occur, are not long-lasting in a long-run equilibrium. And so then the question becomes, well, we already know what happens to output in our long-run equilibrium. Then what about inflation in the long-run equilibrium? What does that thing look like? As I said before, a long-run equilibrium is going to occur where the long-run aggregate supply curve intersects the aggregate demand curve. And so very simply, we have our long-run aggregate supply curve right here. So if we substitute that thing into there, and solve for inflation as a function of everything else, then that's going to tell us what drives inflation in the long run. And so if we do that, it's actually just a couple steps of math. You can see that this is what we get. Inflation in a long-run equilibrium is going to be dictated by this slightly less complicated than what we saw before expression for inflation. Okay, and so again, the question is, what kind of inferences can we draw from this? Well, we can increase long-run equilibrium inflation with an increase in autonomous spending. So again, there's the other piece over there, you'll see. So again, what that means is that that's going to result in an increase in aggregate demand. Likewise, a decline in taxes, T-bar, that also increases aggregate demand. An autonomous easing of monetary policy, that also increases aggregate demand. A decrease in potential output, we'll see what that looks like here in just a second. A decrease in financial frictions, F-bar. Well, again, that's going to lead to an increase in aggregate demand. And then a decrease in lambda. Again, that's going to affect the slope of that aggregate demand curve, and therefore it's going to act a little bit like a shift in the aggregate demand curve. So, but it actually really just affects the slope of the aggregate demand. So I'm not going to go through the example of that, but shifting the slope around means that that is going to impact the ultimate equilibrium level of inflation in the long run. So again, that lambda is important because, as you can see here, lambda shows up there. So if you have a decrease in lambda, that means this denominator is going down. And so since that's on the denominator, if the denominator is decreasing, then this overall term right here is going up. So that tells us equilibrium inflation in the long run is going to rise. And then the others here are pretty self-explanatory, and we'll look at them here in a second. This decrease in potential output, this is the equivalent of a decline in long-run aggregate supply, okay, a decline in potential output. And so we're going to look at these, the long-run aggregate supply and aggregate demand curves in the notebook here, and you can see exactly why, in graphical visual terms, why these changes are going to lead to increases in inflation in the long run. So if we switch to the notebook, okay. So here's our here's the demand side story. And so again, the idea here is that if we have, say, an increase in aggregate demand, then in the short run, that's going to lead us to a point like point B. Over time, that's going to mean that we're outstripping our resources for production in the long term. That's going to lead to higher cost to produce goods. Inflation expectations are going to rise. And over time, we know that the aggregate supply curve is going to drift up so that we end up in our long-run equilibrium. As a result of this initial change in aggregate demand, we're going to end up at point C. And of course, at point C, that means that our long-run equilibrium level of inflation is higher, okay? So just like in the PowerPoint, if we had, say, an increase in autonomous consumption, autonomous investment, autonomous government spending, an autonomous easing of monetary policy, all of those things are consistent with this story where at the end of the day, we end up with a higher equilibrium inflation rate. And then the second story is the change in potential output. So here we have a decline in potential output. So ceteris paribus, with that decline in potential output, once that happens, if we're starting off at point A, then suddenly you're producing beyond your productive capacity. That raises costs of production. Inflation expectations go up. The aggregate supply curve shifts up over time. And in our new long-run equilibrium, we end up at point C if nothing else changes, which again is consistent with a higher long-run equilibrium inflation rate. And so that's the basic story behind these two cases here.